Yeah, let me just, guys, is my screen visible? First tell me this, otherwise, like, because I was
Yeah, many thumbs ups are coming for
okay,
my
okay, yeah, great then. Okay, so yeah, I think we have got a very diverse set of people here, from students to working professionals, and so that's really interesting. And so guys, whatever questions you have around data science or any sort of modeling, like today we'll discuss about classification algorithms, right? So do pitch in, and we have separate like 15 minutes at the end, like from 5:45 I'll just answer questions, okay? And whatever doubt you have, like you are from a non-core branch, how do you move to data science, anything, we'll discuss everything. Or you are from a different industry, how do you switch to data science? We'll discuss it all, and hope we resolve it for you, okay? So let's begin, guys. So keep on dropping your messages, and yeah. So basically, so this webinar will be, so like first introduction would be around data science, okay? So I think you all are interested in data science, that's why you are here. So, but yeah, guys, you need to understand, like data science is now the big deal in the current era, basically. So for the coming 10 years or coming couple of decades, you will see a lot of companies which are going to shift towards data science. Like earlier, like 5 years back, like when I was started, only few companies knew data science. They were not even using it. But right now, they are using it in every domain. This chart can tell you like what all applications are like there in data science. And one of the crazy applications is that if you just want to understand the impact of data science, you can see Tesla. Tesla is a computer vision based company, like which has developed self-driving cars, right? So can you imagine like using computer vision and electric cars? They have built a $1 trillion company. So that's the one of the massive impact of data science. And in our everyday life, we see multiple places where data science is being used. Uh, I'll discuss some examples in the later slides as well, but just okay. A lot of people are making drawings on my screen. Let me.
Sham, I would request you to, uh, take on disable the annotations if possible.
Okay. 1 second.
I'll try from my end as well.
How would I disable this? Okay, let me see. Okay, let me know if if you're able to do it. Otherwise, I will try something else. So okay, so people are. Let me see. Disable. Yeah, this disable. It's disabled now. Yeah, I'll just erase these things. Great. So yeah, guys. So there is a lot of applications every day. So whenever you are going to any website, any e-commerce website, you are buying products from Flipkart, Amazon, right? So you see, right? People who have bought this also bought this. You see these sort of things. So that is a that is an application of data science. And like people who have bought earphones, they are also buying some sort of AirPods, all these things. So using the historical data, every company is now trying to leverage data science. And if you are new to data science, on the right hand side, we can see one chart. Can someone tell me what is this chart called? Just drop in the text box, like what is this chart called? You must have heard of a scatter plot, histogram, bar chart. So what is this type of chart called? I will answer, Sarika, you like at the end. Okay. So this is called word cloud. So to analyze, exactly, Divya is right. So word cloud is something when you analyze textual data. So for text, you need some sort of representation, right? You can't like go through the entire document. So this tells you. So guys, just understand this because it's pretty critical for people who don't know it. So all these words, these are the relevant words uh, from data science, and the size of the word tells you the importance. Like the bigger there's the word, the more important that is. So that's how word cloud are made. And all the people in this like 188 folks are there, right? So you should be able to like answer what these terms are. Okay, every term, what is like quantitative, what is deviation, what is likelihood, what is expectation, what is coefficients, like there are like linear regression coefficients, how should you interpret them? If you want to become a good data scientist, you should be able to answer each and every term mentioned in this word cloud. And yeah, then you can easily be hired, like, because every company is now having data science roles. Okay, we'll move further. Okay, just a second. Yeah. So what exactly data scientists do? So basically, they do a hell lot of things. So you might be thinking like, okay, I'm from this industry. How should I shift to any other industry? Don't worry. Every industry has some application in data science. So if you are cricket enthusiast, you are seeing, right. During the match, they will tell you what is the probable score of the team at the end of 20 overs, right? So even before the finishing, they will give you a prediction. Like it will come at the bottom of the match, like the live telecast. Like 180 is the score which the team will win. The probability of win and loss that you will see, right? The probability they are displaying these days, which one has a better probability. So all these things are application of data science. So if these things interests you, like if you think like, okay, this is pretty interesting to me, and uh, Gartner's chart, are where there are challenges and leaders. What's one second? Let me go back. Challengers and leaders. What challenges? Can you elaborate, Vikram? So basically, it's like it tells you like what all technologies are coming in data science, and in the first chart I explained it. So okay, yeah, great. So basically, all these have matured, like predictive text analytics. These things have matured, but these are very new things which are coming. You can see a lot of technologies are coming in analytics. So that's why if someone tells you like, okay, no, there are already a lot of people in data science, it doesn't need a lot of people now. No, there are so many things coming up in data science that there are millions of jobs coming in. So no worry, don't worry on that. And if you look at this, every industry is mentioned here, right? From e-commerce to banking to retail, everything. So every company, every domain is using artificial intelligence or data science. And so suppose you are operating a retail store, right? You all have visited, I guess, Big Bazaar uh, sometime in your life. Yeah. So how do Big Bazaar manages their inventory? Like how do they know, okay, uh, Dettol is selling like this, like how much stock should I keep in? They analyze data, they analyze the historical records and see like, okay, this has been my historical trend, and this is how much I should keep for the future needs. So every domain, like if you are curious, like, okay, if you don't know like application of data science, just tell me the domain, I will tell you the application. Put it in the chat box, I will tell you the application. And can you imagine, like these days YouTube analyze, okay, HR. So HR is a very interesting, Sudhir. So you asked about HR, right? So a lot of times companies are wondering, right, which employee will leave and which will stick to my organization. So this is called churn modeling. And what you'll do is you can develop models which will tell them like, okay, uh, uh, what all are going to leave. So basically, what data can you capture? Their in time, their exit time, their basically how many leaves are they taking? Like previously they were taking 2 leaves, 1 leave in a month, or 1 leave in a quarter, but now they are taking 2-3 leaves in a quarter, right? Performance, exactly, performance data you will see, like you will get some constant feedback. So there are multiple data you can take and then ultimately predict like what all employees are going to leave your company, or which one are not going to leave your company. Banking is a massive sector, Akash is asking, right? So you all are getting credit card calls these days. Do you wonder like why credit card, or any sort of marketing calls, right? So please take my credit card or take my loan, all these things. uh, how do you how do you think like they're calling you? They see like you are now working, and you are getting some income, and they will not call someone who is not earning. So all the student folks who are in this call, uh, just tell them like whenever you when someone asks you, yeah, they see the CIBIL score too. So CIBIL score is made from all these income data. income data, what has been your different accounts, what has been their balances, all these things. So if you are a student, they will not give you a credit card. Like most likely they will not give you. Tell them I don't have any income. I am a student. They will cut the call. So so basically, out of a billion people in India, how do they know like which one to pitch the credit cards? They will pick the top ones which have all these parameters. Education. See, education is a like massive industry. So these days, people are designing content which are which can be customized. So so in a class you have seen, right, like everyone has a different level of learning, like a different capacity of learning. So there are certain courses which are very basic, and they'll give some examples based on that. And then there are some courses which are like they will use advanced level concepts initially itself. So now courses are designed based on the capacity of like the learning capacity of students. And education is like, yeah, like there is a lot of, and okay, I'll just give you one example which you are using every day. So whenever you order from Swiggy or Zomato, do you think there is a person sitting behind whenever you are asking for any query? Like you go to the help box and then you click, right, you click on your help box, and whenever you get any spilled product, like if the food is not good or you want to make any complaint, you go to the help tab, right, the chat bot. Basically they will give you some options, like click on that and then you type something like, okay, my food was bad, it was less in quantity, or there was some spillage in the food. You mention all these things, right? So how do you think there is a person sitting behind? No, it's like there is a chatbot which answers all these things, and based on your problem, exactly, AI. So based on your basically complaints, they will give you cashbacks. So guys, there is enormous applications. I'll give you some more applications later on, but yeah, you can see the chart. And moving on to the data scientist of the 21st century. So I think all of you want to become data scientists, right? Like, let me see. Okay. So you all want to become a data scientist, and data scientist is just not only about programming or algorithms. It's a mix of multiple things. So you can see, right, primarily there are four different skill sets which are required. First one is maths and statistics. And if like you should be you should have a strong base of statistics, like not just mean, median, and mode. You need to understand different statistical concepts like hypothesis testing, confidence intervals, analysis of variances, t-test, z-test. So these are some things, like once you understand, right, you will be able to apply it every day. But yeah, like you need to understand some statistical concepts before moving into data science, and then move on to the algorithms like supervised, unsupervised. We'll discuss them, but yeah, all these algorithms, I will name a few algorithms as well, which can be very important for all of you to crack any interviews. And in GUVI, we cover all these things in very detail, like from basics. If you don't know anything, it will be covered from basics to the expertise level. So that is the first cohort, like the maths. The second one is the data programming languages, guys. So I think a lot of you are already a coder, right? So, so I hope, like, even if you're not, you just need to learn Python or R. Python should be the first priority, and then R if possible, then SQL or MongoDB, like any data fetching platform, like any language from which you can fetch data, and a language using which you can basically do some algorithm implementation, right? So just remember, like, don't look for many other languages which are there in the industry. Just focus on Python and SQL or MongoDB, whichever is comfortable for you, whatever you have learned. And these are very easy languages. And yeah, it's like cakewalk once you have start coding. So guys, just don't learn things, start doing coding as well. And today we have one use case as well where we can see R programming also in our module, right? So R is not is an optional thing. So we are covering Python in detail because Python is something which is very important, and you will see that it's like from classification to regression algorithms to computer vision algorithms, everything is supported by Python. So Python is something which you should be focusing on, and if time permits, like there can be some R sessions as well. But yeah, probably like Python is the most important one. And the third one is domain knowledge. And domain knowledge is very critical, guys. Like if you are trying to become a data scientist, right? So every domain has a different role, like different. So basically, if you're working in healthcare industry, like you need to understand what is tumor, what is how diseases happen, basically how lung diseases. So you must have heard, right, in news, like a lot of people have developed some models to predict corona, like what all people have corona by looking at their x-ray scans of the lungs, right? So that is also one type of, like, you need to understand the domain as well. Like without knowing the domain, you won't be able to do feature engineering, right? Can someone tell what is feature engineering in the chat box? Only SQL, like one of them is required, Sudhir. So anyone is, how to decide which domain is good to work for? So basically what happens is you need to, if you're already working in a domain, then try to figure out data science roles in the same domain, because that will be easier for you to switch. If you are a fresher, pick the domain which has a lot of jobs. And like e-commerce, banking, finance, it has a lot of jobs. And analytics consulting firms like Tiger Analytics, Latent View, Bridge I2I, Fractal, you can target all these companies. Let me guess, getting the features which impact the problem statement we work. Okay, and what are the definitions you have? Find parameters, selection of features. So feature engineering is, uh, see, suppose you have raw data, right? And I'll give an example. Okay, so there is a person who has taken a loan. Okay, his expenditure was, like 2 years before, his expenditure was 50,000 per month, and his income was 1 lakh, and now his expenditure is 80,000. Like now his expenditure is 1 lakh and his income is 1.5 lakhs. So expenditure has grown up, right? But not uh, so basically expenditure has grown up, but the kind of, like, the income has also grown a bit. So you can't look at absolute levels. Like if you just look at absolute levels, you will think like, okay, this person won't be able to give back my loans, right? So if you look at absolute levels, you won't be able to work, like you won't be able to draw insights from the data. You have to get some ratios, like expenditure divided by income, right? Because if you just look at absolute level, I'll just give you another example. Okay, so one guy is having 20,000 as the expenditure and 30,000 as income, and the other guy is having 1 lakh as the expenditure but 10 lakhs as income. So if you, so which one is a good one? Person A, person one, or person two? Which one can handle loans better? Person two, exactly. How did you answer this thing? You looked at the ratio, right? You didn't look at the absolute numbers. If you look at the absolute numbers, like person two has a higher expenditure number, right? 1 lakh per month. So the model will not be able to understand. Yes, exactly. Yes, expenditure versus salary. So guys, you should be very, like, and why you are able to do this, because you understand, like, okay, expenditure is a part of salary, and this is a domain understanding. You understand, like, okay, expenditure by salary is the actual metric to understand the financial health of anyone, isn't it? So this is like some sort of ratios, some sort of trends is very important. I'll give you one more example, okay, because this is very critical to understand the feature engineering part. uh, let me hold on, because there is another, the project lifecycle example where I will explain to you. But you guys got this example, right? You need to get some ratios. So not the absolute features, some ratios. So this ratio, you take some ratios, you develop some feature variables which are flags where the trend ones. This is called feature engineering. And the last one is, guys, communication and visualization. So you all, like the people who are working in industry, they know, right? If you are very intelligent, but if you're not able to communicate what you have done, it might not work well, right? The businesses might not appreciate it that much. And even students, right? However smart you are, if you don't present it well to the person in front of you, it's of no value, right? So there are a lot of tools which will help you to do this in data science. Like Excel is there, but Tableau or Power BI is also very important tools which will help you create wonderful dashboards and charts. So guys, like these are very important tools which will also get taught in the curriculum. So it's a pretty exciting one, guys. Like it's not like an Udemy, right, where you are just doing one course and then applying it. You will do multiple courses all and cover everything up. And this is the data scientist Venn diagram. So pick what you want to become. Okay. So if you just know communication, you are a hot air basically. Nothing. There is no content. You don't know anything but just good communication. And if you are, so there are different roles, and the perfect data scientist is this place, the overlap of all these domains, right? So target that place. And these are the different roles in data science, guys. Sorry, so basically you can target data analyst if you are new to this domain. You can target so Power BI Tableau is a very smart, like is an advanced tool for visualization, Vikram. So Power BI and Tableau are for advanced visualization, like and making dashboards. MongoDB is mainly used for the different like interacting with databases, fetching data, aggregating data, all these things. Okay, so there are multiple roles, guys. So depending on what expertise you have or what interest area you have, you can target any of these. Okay, okay, and data scientist is something which is a group like is a like it's something which covers everything up, like statistics, data wrangling, machine learning, everything, right? So if you're coming from a developer background, like someone is already knowing SQL a lot, right? Data wrangling is looking at the data, uh, how many missing values are there, how many outliers are there, data cleaning, and looking at the mean, median, mode, distribution of data, charts. You make some charts, right? So data wrangling comes into that. Okay, so great, guys. So do ask questions, guys. Whatever you are feeling, do ask these questions. No one is watching you or no one is looking at you. So however silly the doubt is, do ask. And can you tell us more about it? Yes, yes. Into that. We'll move on to that as well. So uh, yeah. And these are the different tools we have, like in data science. We have R, Python, and data platforms. Like these are the different. One second, guys. I wanna be a data engineer, data intuition. It's 720K in Argentina. Okay, let me. Guys, I'll move to the data classification algorithms as well. Just hold on because there are a lot of people who want to understand the data science, the basics of data science first. Okay, and it's very important. Where is Argentina? Okay, okay, they have mistakenly mentioned. Okay, this is Argentinian dollar, guys. So it's like the value is, I think some peso is there, right? So it's not equivalent to US dollar. It's a different dollar. So, uh, so yeah, the value, the conversion would be pretty less. 720 will be like millionaire, right? So not that much, but yeah, decent enough. And basically, you will earn better than the 90% folks in the industry. So that's for sure. That people have made their salary 5 times in 3 4 years. That's what I can tell you in data science. So be optimistic, keep learning, and these are the certain tools and platforms, guys, you should be aware of, like R, Python, then data platforms like SQL, MongoDB, and then there are some ML tools like TensorFlow, Boost, Anaconda. All these things you should be aware of because this will be used in your day-to-day life, like Jupyter Notebook, all these things, Google Colab. So you should be aware of all these tools, platforms, so that you can implement anything and everywhere basically. And okay, I just want to ask, like, why data science has come into like, which one is better? Okay, yeah, now you understand. Argentinian dollar is 66 rupees, 0.66 rupees. So guys, tell me why data science has boomed in the past 4 5 years. Like, can anyone answer this question? You have seen a lot of roles, right? Today if you just want to see the impact of data science roles, right, on the LinkedIn, go to exactly, Vikram, you're right. Go to LinkedIn jobs and just search analytics, and you will see, and search civil engineer, mechanical engineer, any other job. You will see the count, right? How many jobs are there on the top, like 40,000 results, 50,000 results. You will see. Just compare the results, okay, across domains, and you will understand how many jobs are there. Exactly. So there has been a lot of data in the last 5-10 years, and apart from data, the processing power has also increased in the last 10 years, because if you have data and you don't have processing power, you will not be able to do anything, right? So basically that becomes very important, the processing power. One second. Data driven decisions, exactly, like is majorly about capturing data and then moving to data driven decisions. Okay, so that was it. And just one more very important, this was the important thing, like I think a lot of you are doing guys, you guys are participating in a lot of Kaggle analytics with all these things, but I just wanted to give you a purview of how data science projects happen in real life. Okay, because ultimately you are going to work in any company, and you have to understand, like it's not just about putting a function, like fetching a library, putting a function, and then delivering the output. There is much more to data science. It use market based data, it has exactly, yes, Sudhir, you are absolutely right. Processing power. So basically, can you imagine, like the Apollo mission which happened 50 years back, like the first man which went to moon, the RAM of that spacecraft was how much? Like today we have 6 GB RAM in our phones, right? 6 GB, 8 GB. I don't know, someone might say 12 GB RAM is also there. So 4 GB, 2 GB RAM, at least 2 GB RAM would be there, right, in your phone, mobile phone. It was less than 100 MB of RAM in that spacecraft. So exactly, yeah, it was in KBs actually. So basically that you can see, right, now you have like so much of computational power. No, not 4 KB guys. 4 KB will be pretty less, but yeah, you can check that. And these processing power have enhanced because of Zipf's law. You can like you just like look at the curve, like how has been our processing power. These chips have evolved, right? I3, I4, I5, I9 is coming these days. So even in the last 10 years, you have seen a lot of massive improvement, right? Okay, then let's discuss about the data science life cycle quickly. Uh, so guys, what happens in any sort of data science project? Uh, we do is so first of all, you need to understand business. Without understanding, so let's take a classification example. So today we'll be doing a churn prediction model. Okay, uh, like for any banking customer, what all customers are going to leave me, like basically either they will exit or they will be there with the bank. And it's very important to analyze the churn rate, because it hampers the business directly. So can anyone tell the exact, like tell something more about churn, like what do you mean by churn modeling? Just put in the chat box, what do you mean by churn modeling? Anyone? Because it's very critical for, okay, no idea. Yep. So guys, you know what happens, so all these companies, right, like telecom or banking, which deals with customer every day, right, they don't want customer to leave their platforms, isn't it? They want to work in on their platforms. So what happens is they need to have some sort of modeling in place, which captures, like, okay, what all customers are going to leave and what all customers are going to stay on their platform. And this is called churn modeling, and today we will learn that. Yes, churn modeling is a predictive modeling, because you are trying to predict what all customers are going to leave your platform, isn't it? So so first of all, understand the business, like what is churn modeling. So you understood now, basically, like I'm trying to figure out the people who will leave my uh, basically bank. So we are predicting the attrition rate, yeah, similar to that. Yeah, like what all people are going to leave. So attrition is valid when it comes of in terms of people leaving a company, and churn is like when you leave a product or leave the services of any particular company. So the second step is data mining, guys. So that's where MongoDB or SQL comes in. Like you need to mine the data. Sometimes in companies, what happens, is you uh, like you're working and then you can't like you have to fetch data from different databases, right? There is a finance department, then there is a marketing department, then there is a sales department. So all these departments are there and you can't be dependent on them. So that's why a data scientist is supposed to be good at fetching data. So this is the first process: fetching data, fetching the right data set. And the third step is data cleaning. So basically you are trying to handle missing data, outlier data, or in some type of inconsistencies in the data. Can someone put in the chat box like what do you do with missing data? How do you handle missing data? What do you do with missing data? Like you can replace them using what? Removing data, mean. So guys, just understand this thing. So these answers, yeah, central tendency, you are right. So everyone, you see, everyone is saying this. So in interviews, you have to say something which is not common. So missing data by replacing it by central tendency is good, but there are some certain advanced algorithms like K-NN imputation or regression based imputations, which you should also be aware of. Okay, and you should be able to apply it as well. I can give an example. So we are having income data, right? Income data as one of the column, and remove if negligible, else fill with statistical. Yeah, exactly. Like if you have a million observations, this webinar gives certificate. I am not sure about that. GUVI team will tell you like whether this webinar will give certificate, but GUVI course definitely gives a certificate. So guys, you know what happens? So if you have missing data, right? Suppose there is 0.001% missing data is there, then you exclude it from the data set. But if you have significant like 2-3%, 4% data as the missing one, then what you do is, I'll just give an example. Mean, median, mode, everyone will say, but just understand this because if you get asked this in the interview, you should be able to answer this. Like, uh, so basically, there are income data which is missing, like some part of income is missing, and then there is some educational level. Okay, so there is a data set in which you have two fields: income level and education level, and in some of the incomes are missing. So if you see the educational level, someone is a student, someone is a graduate, someone is a postgraduate, all these things. So if you just impute the mean, a student can't have an income, right? So you will be wrong in those cases. So what you need to do is you need to figure out, okay, what is the mean in students? It will be obviously some zero, right? Some outliers would be there, but it will be zero. So look at the other attribute, like what is the other attribute and what does that say? Like postgraduate, what is the average of income in the postgraduate, and then fill the missing values of income which are there in postgraduates with that mean. Not a global mean, but a localized mean, basically. Do you understand this? Like what I'm trying to say? Imputed with localized mean, not the overall mean. So this is one advanced approach, because you understand, if there is a, I'll give another example, like consider next nearest, exactly. If there is a data city, okay, and there is a state, so you know the cities. So if Hyderabad is there, you can't you will impute it by Telangana, right? So it's like that. Telangana or Andhra Pradesh, sorry, both are there. So if it's Chennai, then the state has to be Tamil Nadu. So basically those sort of relationships you have to figure out in the uh, data and do the imputation. And if you don't have these kind of relationships, use experience, like years of experience in the industry and salary. Build a regression model and impute it. Okay, so using regression also you can impute numeric data. And then there are KNN imputation for categorical data. You can note this down and then read about it. Okay, so just don't be around, just don't say central tendency, mean, median, mode simply. Okay, it won't differentiate you from others. Then outliers is also very critical. We'll discuss that in the code. And the fourth stage is data exploration, guys. So this is also very important. Like you build some hypothesis, and then you test it out. So basically, you will say like the rent of the flats in Mumbai are pretty higher than compared to Chennai, right? So you will check the data of the rental data. You will check, and then you will see, okay, the average flat rent in Mumbai is like almost 40,000 for a 2 BHK, but in Chennai it's 25,000. So there is a significant difference. So my hypothesis is true, but if it's 40,000 and 38,000, it's not that different, right? So your hypothesis is not true, basically. So this also happens in data science projects. Then feature engineering, they're calculating those ratios. I told you, right? Expenditure by income, all those things. You do that, and then you build predictive modeling. So what happens is people directly come and then build predictive modeling. Like they'll just fetch the libraries and basically they start building the models, isn't it? You go to Kaggle Analytics Vidya and then directly take the data and build model. No, there are so many steps before that which happens in companies, and you need to understand this. Okay, because in the interviews or anywhere, a person might ask you like, okay, this is the problem statement. Tell me how are you going to go about it? Like how will you approach this problem? And then there is data visualization, like you put the final results in dashboards like Excel, Power BI, Tableau, all these things. So I hope you got a fair understanding of the life cycle. And this is another example, like, okay, business understanding, data acquisition, modeling, deployment, and then use it basically on web. So these are pretty important. So to understand this entire life cycle, rather than just doing modeling, you need to understand the entire life cycle. What happens if you select a wrong predictive model? Then you don't use it. So that's why. So guys, you never build one model. You build multiple models and you compare the results. And whichever works well, you pick that. You pick that because there is a high chance that you might not be using the right model. Okay. So sometimes yeah, you are not. What is hypothesis? Hypothesis is some sort of assumption which we have. Okay. So an example would be, who is a better player? Uh, Virat Kohli or let me take normal. Tell me any normal one. Okay. Uh, Binny. Binny was there, right? Some player. Yeah, DK. Okay. So who is a better player, Virat Kohli or Dinesh Karthik? So you will be like, okay, looking at the entire performances, you will check the data, right? The runs scored in the historical current form DK, but he has been failing. Like, okay, so Virat Kohli and Bumrah, who is a better batsman? Virat Kohli, right? Virat Kohli is a better batsman. How are you saying this? This is a hypothesis. So you are assuming like, okay, Virat Kohli is a better batsman than Bumrah. And if someone tells you like, how can you say that? Look at the numbers, bro. Basically, right? Look at the T20 numbers, ODI numbers, batting numbers, right? You validate with data like the average of Virat Kohli is 50 and Bumrah is 5. So this is a data analysis. But if someone asks you, who is better, like Virat Kohli or Steve Smith, you might get a bit confused, right? Since no, Bumrah's role is different, but obviously I'm comparing as a batsman. Obviously, who's a better batsman than Virat Kohli is, right? But if you're comparing with Steve Smith or Joe Root, then the averages won't look that different. It will be, some people will say Joe Root, some people will say Steve Smith. There is not a clear distinction, right? For us, it's Virat Kohli, obviously, as an Indian, but but at the debut we can't do. At the debut we can't do any hypothesis. Hypothesis is only done when you have like some data and you can validate it with data. So either you say like, okay, your hypothesis is correct or your hypothesis is not correct. Okay, so that's how you do. Like, okay, if some statement is like some statement is called a hypothesis. Like like, okay, this is most probably the thing. And yep. So a generic statement is called hypothesis, and then you validate it using historical data. Okay. So guys, basically now we'll move on to the algorithms part, and today we'll be looking at the classification algorithms. But first of all, you need to understand like there are different classes of algorithms: unsupervised, supervised, reinforcement. Okay, and supervised learning is something where you have a particular target in place. Like you have so suppose in churn modeling specifically, right? You knew like what all people have left your company in the past, right? And based on that data, you will predict in future, like okay, a person with this sort of uh, data have left it. Basically, like in case of banking customer whose expenditure was rising and whose income was not rising, ultimately he will leave the bank. Like he will close the account or he will do something, right? Or if he's not using the bank, like there is no transaction happening from the last 6 months, he will leave the bank ultimately. So you had some historical data where you had labeled like okay, this is a bank, and like these guys have left the bank, and you have targets like okay, 1 and 0. So whenever you have targets, it's called supervised, and whenever you don't have any targets, it's called unsupervised, like clustering. I just give an example of clustering, and we will move forward. So, do you think when you watch any sort of YouTube videos or Hotstar, you all are looking at the same advertisements? Like, can someone write in the chat box? Do you think all of you are looking at the same? Why? What are they doing? So we know, no, based on our history, yeah, profiles, demographics. Exactly, guys. You guys understood it. So basically, if someone is a student who is going to like someone is in class 12th, right? He will be seeing advertisements from big universities. Someone who is already working, he will be seeing advertisement of a lot of cars, right? A student will not buy a car more, right? Like the chances are pretty less. So a working professional will see the advertisement of tires, cars, all these things, insurance companies. You a student will be seeing advertisement of bikes. College student will be seeing all these advertisements. So based on your demographics, you see all these ads like age, student. Like whenever you log into these portals, they take all your data, like what's your history, everything they will capture. And if you skip any ad, they will know like okay, this guy doesn't like these kind of things. And if you watch the entire ad, they will understand like okay, you love these ads. So that's called clustering. They will make profiles, and every cluster is shown different sort of advertisements. So I think, yeah, now we'll move to the algorithms part, and this is the word cloud from data science algorithms. So guys, like just focus on understanding every dimension of data science, right? So from classification to clustering, I'll give you primary like top models which we use in data science. So we start from linear regression, we move to logistic, decision trees, random forest, XGBoost. So all these algorithms are very important. And then K-means in clustering, you can note it down. And because if you are planning for any like data science roles, you should be in depth. Like uh, you should have an in-depth understanding of all these algorithms, and how do you compare these algorithms, why they are good compared to other ones. All this is very important. Okay, so okay, can someone tell me like before, like I'll move on to the code part now, basically some implementation. So what is like what do you mean by classification? Like what do you mean by classification algorithms? Any example you know of, like where we use classification algorithms apart from the churn which I just discussed? Yes, news classification is a text analysis, text analytics. So it's a pretty interesting problem, guys. Like in news, Google receive every day like millions of articles. Like like, do you think that someone is sitting at the back end and classifying like, okay, this is sports, this is market news, this is entertainment? You just go and click on these tabs and you see all these articles. But do you think anyone is working? Yeah, email spam detector, sentiment analysis, right, guys? All these low default smokers, small smokers. This is great. So you guys understand classification. Great. Let's deep dive into this and understand it in detail. Okay. So if anyone doesn't understand, just put that in the chat box. We'll discuss. But yeah, let's move into that. I think, yeah. So basically, what was the first step? The first step is you should be aware of all these libraries, like what NumPy does, what Pandas does, what Matplotlib, all these things. So Seaborn and Matplotlib are what what k-means clustering. Okay, so k-means is you make clusters, right? So I'll just give you. Okay, we'll discuss this in the end, Bhavish. Like just drop this question again at 5:45. We'll discuss that. Okay. Um, I'll move to the classification algorithm today because it's pretty important to understand. So these are the important libraries, guys, and you need to understand like, okay, what is the significance of each library? Pandas is used for data manipulation, data wrangling. Manipulation, wrangling are similar things. So that is the first thing. Now we are looking at the churn model. Like, okay, we are loading the data and let's look at the data. Okay, df dot head. So we have these data set, like these are row number is just the ID, okay, and this is the customer ID. Then surname, okay, Hargrave, Hill, Onio, Bonnie, Mitchell, okay. Then this is the credit score. What is credit score? Someone told about credit. What is credit score? Yes, Jacob, I will share this as well, okay. What is credit score? Like CIBIL is in India, it's called CIBIL. In other countries, you have FICO. In US, it's FICO, Experian. In India, you have CRIF score, CIBIL score, Experian score. All these scores are there. But what is credit score? What do you mean by credit score? See, you need to understand domain first before building the solution. So what is credit score? What do you think? Payment capacity. Exactly. So a high civil score is good or a low civil score is good? Exactly. What is the highest possible civil score? 900 is the highest possible score. Yeah. Okay, so you have 777. Good. Maintain a civil score above 700 because I work in credit industry. So I know I have built all these models. So guys, so credit score is very important to understand. Like this depicts the financial health of any person. Yeah, guys, there is some issue with my charger, and I will change the battery basically, like the charger. Yeah, make sure you are plugged in. Yes, guys. There is charger plugged in. I'm using a backup charger, which is of small capacity. So no worries. I think it's working from last 1 hour. So geography is France. Like which place is there? Geography is also very important, guys. If you are uh, like if so, people in Sri Lanka, like you know about Sri Lanka crisis, right? They are currently having a very hard time to take loans and do something around it, like loans and everything. So geography, like location, also plays a very important role. Gender, age, tenure with the bank, basically. So an old customer is less likely to drop in, right? So I think like, okay, you must have been using all these credit cards, like these accounts, right? Bank accounts. So the older ones, it's like, okay, it's very difficult to close these accounts because that account has a lot of information and you want to stick with that because that's been your oldest one. But sometimes the new ones, you don't have a lot of dependency on that. So tenure is also very important. What is the balance? See, this guy has a zero balance and he's not holding any balance. So he has exited, like over time, he has exited the bank and has a credit card. Okay. So he has a credit card, number of products he has, like credit card is one product, then personal loan, any sort of loan is also one product. Okay. He's an active member. Active member means he must have done some sort of transaction in the last 1 month or something. Okay. What some definition sort of thing. And estimated salary. What is the salary? This is your data. This is your raw data. And exited means which one has exited your bank. Like one is exited and zero didn't exit. So right now we have 1000 rows and 14 attributes, out of which this is your target, right? This is a supervised learning, and target is your this exited. Okay, someone. What is the delimiter comma? Yeah, guys. So it's a CSV file. So delimiter is comma. If it's a tab, if it's a sometimes you will see this. in text data. So sometimes you see a space. So how the data is, so CSV file means comma separated. Okay, so that's why delimiter is comma. Okay, now I'm checking the null values, guys. So basically, if you check this, the null values, all the columns, there are no nulls. But I've already discussed, right? If you have nulls, how would you treat them? Mean, median, mode, some sort of regression, all these things you can use. Okay, this is a perfect data set right now. N unique, what does N unique tells you? So N unique tells about the, sorry guys, sorry, I had sneezed. Okay, so basically, guys, so this tells you how many unique values are there in the each column, and why it's very important to check, because you knew that you had 10,000 rows, right? 10,000 rows. So Sheikh Anwar Ali is asking, I'm a mechanical engineer working in non-IT sector. Can I be a good data scientist? Yes, I was a mechanical engineer, and I am one of the like I am a senior data scientist. So at my company, like, and so no worries, Anwar. It might be a long journey, but you can obviously do it. So I have done my graduation from IIT Hyderabad in mechanical, and after that I have been in data science from 6+ years. So guys, uh, don't think like if you are mechanical or civil engineers. All my friends are yes, resume making. GUVI will help you in that as well. Okay, don't worry. So why it's very, where are you employed at currently, please? I'm currently working at TransUnion, and yeah, and if you think like okay, mechanical engineer and all won't be that great in data scientist. So I'm telling you, I'm leading the India team here. So don't think like okay, you can't become a data scientist. If you're good, right? If you're good at a domain, you will do very well, guys. So that's what I can say. Okay, coming back to this. So n unique is something when you check the number of unique values across all these columns, and if the number of rows and the number of unique values are same, which means it's an ID variable. Okay, that's the only check we have to do here. So these are ID variables. They are different for every value. So that's what you drop these values now. Okay, all these ID and surname. Surname doesn't have any sort of information, right? Can you decide whether someone will drop from your company or not based on the surname? No, it's a wrong policy. In US, you can't even do this. Otherwise, you will be fined. So guys, do understand. No use of. Uh, okay, I think it has been already dropped. So I had to run this earlier because there was some modeling work which we had to do, tuning work. We'll go to this part. Okay, so we dropped these three data sets, these three columns. Okay, and after this, you have this entire DF data set. So you have all the relevant data. So uh, these are called predictors. Okay, predictors, independent variables, and this is called dependent variable, their target. So that's about it. And then you look at the data types, like what are the data types are there? Integer, objective, like what all are there? So object means categorical data, and integer means numeric data. Can someone tell me the type of object data? Like, can someone tell me what is nominal and ordinal data? Difference between nominal categorical data and ordinal data. No, 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 no. Ordinal is not that. So exactly, Surya is right. So ordinal is when you have some sort of order, when you give some sort of rating, right? 1, 2, 3, 4, 5. It's like, or you have like poor, good, best. So there is an order, right? Best and good is near, and best and poor is very different from each other. So there is a ranking. Data which defines ranking is called ordinal, exactly. And nominal is just numbers. So yeah, this is. So I asked about the ordinal and nominal, and I think I want to make a chat. What's, yeah, we'll discuss. Saida. We'll discuss everything, guys. Okay, just and do ask these queries at the end, like from 17:45. I'll discuss all these questions. Okay. So now the second step I told you, right, about exploratory data analysis, and you have to basically look at the data. You need to see, like, first of all, you see the distribution of target. How many people are retained, means stayed with the bank, and how many people exited the bank. So almost 20% exited the bank. So yeah, you are using plots to figure out, like, this is the plot of this, the churn, like the number of people churned and number of people didn't churn. So the second step is, once you have looked at the target, you look at the different geography, okay, and distribute the exit and non-exit. So guys, just think from a company perspective, okay? Don't just look at it as a project. Company perspective, think this is your bank. And now what you are seeing is, in France, people are not dropping that much. Like, one is this orange is the exited, right? In Germany, you see a lot of, like, this proportion is very high, but here the blue is very high compared to the orange one, but here it's almost equivalent, like 50% of this. So Germany, there is a lot of drop. So you need to focus in the German market, right? So someone was asking me about hypothesis and all. So so you see, you can bring this inside, like, okay, Germany is facing a lot of uh, drop in the customer compared to France. Then in male and female, it's almost similar, but yeah, female are still dropping more than the male ones, right? So there is something wrong with them. Like, basically, the services which are they are providing are not sufficient for female. Like, they're just targeting males. So it's they need to change. Basically, they need to give something else as well. Has credit card, it's similar. Like, there is not a big distinction between this. And again, is active member. So the people who are not an active member, you see a higher proportion of exit, right? It can be clearly shown from this plot. So as a data scientist, you should be able to generate these sort of insights from the data. Okay, this is what the client expects at the first step. Second step is creating box plot. These are categorical data, right? Isn't it? These are categorical data: geography, gender, active, headscarf. But if you have numeric data, how do you analyze them? You create some box plots or histograms, all these things. But box plot gives you, this is a bivariate. Can someone tell me what is bivariate analysis? Yeah, Ankit, my charger is, I'll keep it here. I can't help it. I need to get a new charger. There is something wrong with my older one, which uses two variables. Exactly. So univariate, when you have only one variable, when you are analyzing one variable, like histogram, bar chart, all these things. Bivariate is when you analyze two variables. Multivariate is when you analyze 2 plus variables. So this is a bivariate, isn't it? So what's the insight? Can someone tell me, like, I will explain about box plot detail, but can someone tell me what insight can you sorry guys, what insight can you draw from any one of this? Can someone tell me in the chat box? Okay, what is like, what are the other uses of box plot? Can someone tell me? Outliers, exactly. Ramesh has answered correctly. Divya is also right. Outliers. So guys who don't know, there is lots of black sheet in second chart. Yes. Let me annotate now. Okay. You guys have annotated quite a lot. Let me. So these are my outliers, which are beyond these whiskers. So what happens in, so basically, uh, any value which are beyond these whiskers, these are called whiskers. Okay. These are also outliers, and these are also outliers, which are below these whiskers. And what are these whiskers? So basically, this is my first quartile. This is my second quartile, which is called median. This is my third quartile. Can someone tell me what is quartile? Okay, no one. Quartile is 25th percentile. Exactly. So yeah, right. So basically, this is your interquartile range. Whiskers are found beyond 1.5 times of the interquartile range. 1.5. times the interquartile range, IQR, this range. Okay, IQR basically. I have a very bad handwriting and mouse doesn't help me much. So guys, so that's how you identify outliers. But Boxplot also tells you about, let me clear everything. So Boxplot also tells you the distribution, like exactly, Sudhir. So also tells you the distribution. So what it says is, in the age, basically, once again, let me pick this one. Which one has a difference? Yeah. Okay, balance. So the people who have exited, like, so the range is quite high, right? This range is quite high. Like, this is the range for people who didn't exit, and this is the range of people who exited. Okay. Let me pick something else as well. Age. Okay, so what it tells you is what is the distribution of people who have exited and who didn't exit. So what it tells, like, okay, the balances have been varying from 0 to 2 lakhs or something, right? In case of people who didn't exit. Okay, so this is means people who didn't exit, and this is one means people who exited. And what is the distribution of balance between people who exited? Okay, and what is the distribution of balance between people who didn't exit? And if there is a massive deviation, like you see tenure. So tenure is something like how long you have been associated with the bank, and it's pretty small in this case. And in this case, it's pretty like the variation is quite high. So that these are some, there is like, but there is no significant insight which you can draw from all these things. Like, so what does it mean is, uh, you can't differentiate based on just one feature, like based on just balance. You can't say whether someone will churn or not. Okay, otherwise you don't need any advanced algorithm, right? Any sort of an algorithm. So what we do is, we now go to the machine learning implementation part. Close this up. Yeah. Like, we will use machine learning to identify which one will churn and which one will not churn, because here it's not that different. Here there was some clear thing, like Germany people were different and like churning, right? And France were not churning. But here there was not a exact difference. Like here there is a bit of difference, like age. You see, people with lower age are not churning, but people with higher age, like this is starting from 40 to 55 or something, these people are churning a lot compared to these people. Okay, so higher age is what the people are churning more. And yeah, man, you see, we had this data balance, and we also had salary. So I told you, right, sometimes you have to take the ratio between these two to figure out which one is, to find the exact financial capacity of any person, right? So just use balance or salary will not help. Take a ratio of this. So this is called feature engineering. Okay, let me, yeah. So you are creating a feature here. Balance by estimated salary. Okay, and then you see, so there is some difference here. Like the ratios are a bit higher for the exited ones. Like there is a lot of balance. So people who are not able to repay their balance means loan amount. Okay, balance means how much money you have to pay back to the bank. So the people whose balances are more, and they're like basically whose balance to salary ratio is higher, they are in a financial stress, right? They are in a very high financial stress. So most likely they will exit or they will default on their loan. So that's what they do. So we create that. Then we also create features like, okay, tenure versus age, because like tenure means how long they have been with the bank, and divided by the age. So this is also one metric. It might come out to be important, might not come out to be that important. So tenure divided by age is also one metric. Okay, and then you have credit score divided by age. So like, so you know what happens in feature engineering, you try to create all sort of features which are possible. Okay, so if it comes out to be good, then good, otherwise you can obviously like leave them, right? But yeah, try to create as many features as possible which can come out to be significant. Then data prep for modeling. So basically, once you have these features, now you will move into the data preparation part. Okay, so yeah, so these are the continuous variables. These were the categorical variables like has credit card, active member, geography, gender. Okay, so these are the, and in training, so basically this is your train data. Okay, so let me, so this is your training data. You're combining exited plus continuous variables plus categorical data, all of it, and this is your final data set basically. Okay, for model training. There is some more normalization which will happen, like we'll discuss that. So basically, you do some one hot encoding. Okay, 1 minus 1, basically not 0. So whichever has credit card, you are just making it -1 rather than 1. Okay, because it's a negative metric, something like that. So you just make 1 and 0 rather than 1 and 0. You are just making 1 and -1. Why do we do that? You know, because it gives a directional effect in the data. If you just keep 1 and 0, it's fine, like you can keep that, but giving it 1 and -1, it creates some sort of directional effect in the data, like it's entirely opposite with the data set. Okay, df is a variable. No, df is the data frame, data set. On the basis of training, we are going to build predictive models. Yes, so you have a separate you will have a separate data for test, and there is a test data and train data basically. One second. So currently this is, we are working on train data. We have a separate test data as well. Okay, so what we have done is once again, yeah, we have converted this 0 1 to 1 and -1. Okay, and now we have encoded. Can someone tell me what is one hot encoding? Yes, not 20-80, 80-20, 80% train and 20% test. It can be 70-30 as well, like no worries guys, like 75-25, 70-30, 80-20, whatever you need. Can anyone tell me what is one hot encoding? So you convert these features into, so basically what happens is, whenever the feature is, let me give you an example. So whenever the feature is Spain, it becomes 1, and all the other will become -1. So others will become -1, and whenever like the country is Spain, it's 1. So you create, earlier we only had one feature, right, called geography, and you had Spain, Germany, France, all these things. Here you see geography, Spain, France, Germany, and now we have converted that into a long format, like geography Spain. Whenever Spain is there, it will be 1, otherwise it will be -1. So first one was what? Spain, right? Spain. You see, it's 1, and others are -1 because they are not there. In other case, the second one was France. The second one was France. So you see 1, others are -1. So this is called one hot encoding. Basically, you create multiple feature from one base feature, and this is done for categorical data. Okay. And guys, now what we are doing is we are trying to scale. Can someone tell me like why do we do scaling? Oh, why are we converting? Okay. Into number to, why are we converting? Because ultimately we want to figure out some differences, right, in terms of numeric distances. Like, okay, in terms of numeric, you will be able to calculate the errors better to accommodate large variation. Yes. So why do we do a scaling? To make some same range. Exactly. So guys, I'll tell you one thing. So there are two numbers. One varies from, like, income is varying from 1 to 10 lakhs. Okay, income data. and credit score was varying from 1 to 1000, right? 900 or something. So it was, the variation was quite less for the credit score, but income it's very high. So income will have a lot of effect on the model, right? If you don't scale it up, if you don't normalize. So in case of logistic regression, you should normalize it. Otherwise, a like the error in income will impact the entire model's performance, guys. You should understand this. Like error of 10 in income is not equivalent to error of 10 in any other score, like credit score. In income, you can have an error of 1000, which is possible because income varies a lot, but credit score won't vary that much, right? So you try to bring them on the same scale so that they have a same impact on the model. Yes, exactly, Vikram, you're right. So Divya is also right. So great, guys. So that's why we do scaling, and there are two ways of scaling. One is standardization, and the second one is normalization. We are doing normalization. X minus minimum value divided by max minus minimum value. Do you understand this? And there is a normal score normalization based on z-score based normalization, so which is different, which you can go through and you can read up, but this is the common way, like x minus minimum, max minus minimum. So this is, now you will see, okay, everything has normalized. You see, all these values are now normalized. They are now on the same scale. They will not impact, they will impact data similarly. And now what we're doing is everything has been converted into one particular function, so that whenever you call this function, everything will happen automatically for any data set. Okay, you don't need to do it every time. You just call this function, everything will get corrected. So now we have this data set ready, right? We have this entire data which is normalized. We have done one hot encoding. We have converted 0 and 1 to 0 and -1. We have got some ratios as well, right? Balances, balance ratio, balance salary ratio, all these things. Now we can develop the model. So can you imagine the difference from where we started? Like we had a very basic data, right? Now we have a very like we have some normalization, feature engineering, those things. And guys, so any modeling step. So someone asked like how to how do you know that we have picked the wrong model or right model? So what you do is you pick multiple models, and then you basically see which one is working better. So in this case, we have three different models: logistic regression, random forest, and XGBoost. Okay. So you need to understand like logistic regression, so basically this is like, yeah, this takes a lot of time to run. So that's why I've already run this. Let me see, this will run faster because, okay, 1 second. Okay, I think, see, so can someone tell me like what are these parameters? Like I'll go to the boosting part because that is very important to understand. What are the parameters in this random forest? Can someone explain like what is max depth? Level. Guys, see, here comes the understanding. Like you need to understand each and every parameter of these models. Okay, so this is logistic is a very basic model, but yeah, you can still try multiple things, and you see the performance is 81% in this case, and in this case the performance was 86%. You see, so that's why it's, and even in case of XG boosting, the performance was around 86%. So what happens is you need to understand these two models in very big detail. Like, okay, what is max depth? Depth is how deeper your tree are built. Like basically you can have a tree with 3, 5, 6, 7, 8. So what we are doing here is we are giving all the parameters and we are doing some sort of grid search. Like grid search. So these are the primary parameters. And so basically, see, what are the primary parameters? Min sample split, an estimator, max features, max depth. And then what we do is, we don't know which value of parameter will work well. So we iterate through everything and we figure out like which one is the best one. You see, we got highest performance as 86%, and the best one was with max depth 8, max features 9, minimum split 6, estimators 50. Okay, so this becomes your final model. This is your final model, basically the best model. So guys, max depth is how deep you are making your tree is. So basically a tree can be of 3, 5, 6 levels, right? Do you guys understand the the levels of trees? Are these your code? Yes, yes, yes. We'll share the course. Everything we'll share. Okay. Experience sample split. Yeah, we'll share that. So basically, see, guys, just hold on to this, and we'll understand each and every parameter. Okay. So, and these two are very important. So that's why I'm going these in detail. So max depth is how deeper your tree has been built. Okay. So simple trees are of depth of 2 or 3, but advanced trees are of 3, 5, 6, 7, 8 as the depth. Okay. So depth means how many levels in your tree are, like how many levels are there in your tree? From the starting level, how many level deeper you are going. So the deeper you go, the chances of overfitting increases, but it also gives you higher performance. So that's the thing. You have to understand like, okay, what is the right depth? Max features is how many features should you be using in your tree at one time. So 6, 7, 8, 9. How many features we had in the model? We had somewhere around, let's see. We have 17 features, right, in our model, and one is the target. So you give something around 50% of that, like 17. So 50% is about how much? 6, 7, 8, 9. So you give these many features. Like how many features should you be using for every tree? So random forest is a group of multiple trees, isn't it? Exactly. Max features for data structure. Are these the same tree? No, 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 Rufia. So it's a different tree. So basically what happens is you have one decision tree. Let me show you a decision tree, guys. Okay. Just give me a second. I'll show you a decision tree. Okay. Just give me a second. Because that is an important concept, and we will yeah, let me share my screen back. Just a couple of minutes, folks. We'll be looking at it soon. Yeah. How many of you guys know decision tree? Like, is someone doesn't know any decision tree? I thought like people are aware of these things. Are you guys who doesn't know decision tree? Okay, guys. I'll just give you a very brief introduction about decision tree. Okay, so it will look something like this. Okay, so what happens is we are trying to make some sort of rule in the tree. Okay. And this is the depth called how many levels in the tree. Like this is the first level, second level, third level, fourth level. This is a 5 depth tree. Okay. So let me give an example through a very simple thing. So just imagine this case. Okay. So if I give you a data of rainfall, like every day some rainfall has happened, right? So if I ask you what is the probability of raining today, and you are like, okay, let me give me some data. So which date it is, which month it is it a raining season or something like that? So these data points you will ask, right, to tell someone like whether it will rain today or not. So what decision tree tells is it will give you something like this, like if it's a rainy season and if it has rained yesterday, then there is a 80% chance that it will rain today. It gives you a rule, like if like a rule in terms of if, like okay, if it's a rainy season and if it has rained yesterday, then you will have 80% chance of raining today. And if it's a summer season and it was sunny yesterday, then there is a 5% chance of raining today. Are you guys getting it? More like a flow chart. Exactly. Branch based decision. We all have done this thing. Exactly. So we do this sort of branching, like how things will happen. And so basically, so play cricket. You can see this example. Okay. So there is a class of 30 students, and I think so. What happens is 15 people play cricket, and so if you split based on gender, 10 are female and 20 are males, and 2 play cricket in female, which is like 20% and 65%, and in male 13 out of 20 plays cricket. So it's like 65 and 20% based on gender. And if you just split on class, like class 9 student and class 10 student, it's not a good separator, right? If you just split on class, like okay, 9th class 43% plays cricket, 10th class 56% plays cricket. So it's not that separative, right? Gender split class, but gender is like okay, cricket, like there is a quite difference, like 20%, 65%. So which one will you prefer, class or gender, to use in the tree? Can someone text? So if you have to predict, yes, if you have to predict which one, what people are like, which one is more likely to play cricket, then which one will you pick? Gender, right? Exactly, because it has a very separative feature. It clears the no, not class, Sarath. Class. So the difference between class is 9th is 43%, 10th is 46%. It's not that different, right? But gender is 20%, 65. There is a massive difference. So if I tell you like okay, someone is female, what is the probability of her to be playing cricket? 20%, right? You can, it's a like okay, 20%, and for male it's 65%. So it's a very different. So that is how like purity is calculated. So these entropy or information gain concepts, all of these are located based on these separative nature of the features. So you will use gender as the variable in your tree, not class. Okay. So yeah, like these are like, this is how you make trees, and ultimately you make something like this big tree. Let me go. Yeah. So if you have to classify certain diseases, right? Or some anything, so it will go like this, like yes, no, and it will all have probability. There is no yes and no. It's like 90% chance of yes, 10% chance of no, all these things. Okay. So yeah, guys, so you get ultimately like this. And random forest is a group of decision tree. Like there will be hundreds of tree which will be made by like random forest. Like, so random forest, can you like imagine, like it's the name itself is forest, right? One second. Yeah. So what it means is you have multiple trees, and you take the decision of every tree and average it out, basically. Because sometimes you can't make one tree, it will be biased, isn't it, if you just use one tree. So random forest takes multiple trees, and that's what called n estimators. Trees are called estimators here. So 50 tree or 100 tree. So you can use these two. You can also use 200, but yeah, we have used 100. And then minimum split is 3, 5, 6, 7. Minimum sample split, which means whenever you split, right, at least these many samples should be there in the tree. So in this example, when you are splitting, there are 30 students, right? At least. Then you're splitting. So at least there should be 3, 5, 7, 6 or 7. So this is called minimum sample split. So to split, there should be at least this much size of the leaf of the node, basically. And these are features, like how many features should you be using in the decision tree. So basically it's 100 decision tree or 50 decision tree, and you are picking which one works well. Okay, so how many combinations are possible, guys? Can you see? 4 into 4 into 2 into 4. 4 into 4, 16. 32 into 4, 128. So there are 128 different combinations of random forest running, and it has told this is the best out of 128. Isn't it crazy? See, these are pros and cons means. Okay, class. I'll tell you. Okay, on what basis we are giving these numbers for depth and features? See, depth is like based on business understanding. We know like we should not go beyond these like 3, 5, 6, 7, 8. You have only 16 features, right? Okay. I'll tell you the logic. So let me copy this out. So sir, can you unmute me? I'm not able to unmute anyone, guys. Like I think no, we can only chat, put in the chat box. So guys, just I will tell you, like first of all, I will tell you this 128 logic. Okay, so if I remove all these parameters, just one parameter for every value, like for every estimator I have one value. So this is one random forest. Okay, can you imagine? This is one random forest, and if you have, and the grid search tells you, so there are multiple possible values of max depth and max features and n estimators, minimum sample split. So grid search, what it does is, you don't know whether 8 is correct or right, isn't it, Aditya? Like there can be 7 possible, right? 6 is also can be possible. You don't know. So what you do is you give a set, like vary it from 3 to 8, vary it from 6, 7, 8, 9, vary it from 50 and 100, vary it from 3, 5, 6, 7. So how many possible random forests can be made? 4 into 4 into 2 into 4. Isn't it 28? 128. Guys, did you understand this concept? Yeah. So there are 128 different random forests, and you are trying to pick the best one. What is 5? Which 5? Sweta, which 5? Okay. So guys, this is what grid search does. So you should be aware of this particular function, because a lot of times, you know, whenever you go for this competition, you just build a basic random forest and then tell like, okay, this is my performance. No, you have to figure out which one is the best one, because you see, if I run this, you will see. The performance is different from this one, right? The performance is different from, like, this is a different one, and 7 and 100, yeah, and the performance is a bit lower compared to this one. So the grid search gives you the best performing hyperparameter, and you should be like, and similarly for what is like Manhattan distance. No, Manhattan distance is different. It's like it's an absolute distance between x and y, right? So Manhattan is different, so it's a different thing. So guys, so that was about random forests. It's a group of multiple decision tree, and ultimately you use the aggregated results. And for XGBoost, it's a parallel decision tree. That's what I can say. So if anyone asks you, it's a series one. It's like guys, see, the thing is, if you don't know anything at all, you need to take a course which will where we explain everything from the very basic. I have to cover all this, so that's why I'm telling you. Just understand the difference. Like this is a series of decision trees, and this is a parallel decision tree. And similarly, we have parameters like max depth, gamma. Gamma is a different one. Learning rate is a different one. Estimator is same, right? How many decision tree you need to have, and minimum child weight is also different. So I'll tell you what is this. So gamma is you try so parallelly you make one tree out of the first you make one simple tree, then you again whenever you have mistaken, right? So suppose I'll just give an example. So in the same thing, just 1 second, guys. So GUVI team, will the marketing pitch happen or not? Hello, Shivanjali, am I audible to you?
Yes, Sham, you're audible.
So will the marketing pitch happen today?
Yeah, is the session done now?
No, it's not done. Okay, I will give me 5-6 minutes and then I will quickly wrap this up.
If you would like to end up here, then I will ask Lokesh to pitch in.
Yes, just give me a couple of minutes.
Sure,
Okay.
no problem. Take your time. No
Yeah.
problem.
So guys, what happens is you have multiple parameters again in boosting. So it's very important to learn the difference between random forest and XG boosting. And random forest is a series of series of decision tree. These are parallel decision tree. Like a lot of decision tree are running together in one go. But in the gradient boosting, it's a series, like one tree run and then another tree runs after that, because it tries to reduce the error one after the other. And max depth is the same concept, like how many levels you have in the tree. Gamma is if your tree is doing some mistake, how hardly you want to penalize those mistakes. 0, 1 is high value of error classification weights. 0, 0, 1 is lower. So you can also have 0, 0, 0, 1, all these things. Then minimum child weight is at the end of the sample, right? How many data points should be there? At least how many data points should be there? So that's what it tells you. Like at least 1 point, 5 point, 10 point should be there. Learning rate is also similar to whenever you misclassify, there is a gradient boosting method, like the gradient descent method is being used. So it amplifies, if you have a higher learning rate, you don't need a lot of trees, you just need 10, 15 or 20 trees to learn everything up, and then you can have the results. But sometimes it does overfitting like that as well. So that's why we need to check multiple parameters. And n estimates is similar to number of trees, like how many trees you want into the model. Okay, so 5, 10, 20. We'll discuss all this in detail during the coursework. But this is what you should understand. And any interview question as well, they will ask you like what are the different parameters and how does it affect. So grid search CV is what you should understand. There is some error which is happening because I think it got minimum impurity split. I think let me check this one. I'll correct this up and then send this file to you, because it was a massive code and it was taking a lot of time. So I think this will not run because we have to run this part as well. So guys, but we have got the best model here. It's just about the fitting the best models. This is the main part. Like how do you find the best tree out of the entire how do you find the best parameter for the random forest and boosting? And these are the different hyperparameters. And as I've shown you, this is how a tree works. Like you make rules, you make a flow chart. So that's how tree works. And these are different concepts like decision node, leaf node, uh, path, parent and child node. So all these concepts will be discussed in detail later on. Shivanjali, you can have the pitch, and then I can take some Q&A at the end. Yeah, I have changed. I ran the grid again. So basically that's why I have to run it again and then it will happen. And that grid takes a lot of time. So you're right, guys. And you will learn these. And if you learn these things right, and I don't think there will be a problem. If you learn all these implementation, then you will be good, guys. Like you can work in any company. Yeah, Biju, I will share it. I will share this. I'll share the file and the notebook as well, because I have to do some changes. I have to make those changes and then I'll share it. And see, guys, neural nets are also used in classification algorithms. So you should have a basic idea of what are layers, what are hidden layers, what is the output layer, relationships, everything. So to become a good data scientist, you need to have an understanding of all these very clearly, okay? Because these things are used in every space, like from handwriting recognition to classification. The only drawback is you won't be able to. So decision trees are very intuitive, right? I told you about that, and you easily understood it. But neural networks is a bit convoluted, and it takes like some sort of experience with the code and all everything to understand this. But it's not that difficult, so you can easily understand it. Yeah. And got 98.6 as my R2. I dropped some features and I got 6. So basically, you have to look at adjusted R square, not just R square. If your adjusted R square is, pick the one which has higher adjusted R square, Lakshmi. Okay, because sometimes you can't. So suppose first model is having 100 variables and second model is only using 10 variables. So, and if the difference between R square is not that much, then you can pick the one which is using lesser variables. Okay, so look at the adjusted R square number. You will get the best model. C parameter is the intercept. So basically, when everything is, when you don't have any sort of data, so then what is the mean value? So that's what C value tells. Sir, K-means clustering. Yeah, K-means clustering is like it's used to segregate people. Basically, like I told you, right? I showed you these things. One second, yeah. This is a K-means clustering, guys. So you cluster based on distances, and here you use Euclidean distance. I'll mention Euclidean distance.